Last one. It's the difference of two perfect squares. So you could factor it to be 2x plus 2 and 2x minus 2. That would be acceptable. You could also factor out a 4 and you're left with an x squared minus 1, which would basically be 4x plus 1 and x minus 1. Okay? So if you look at that, your roots are going to be simple. They're going to be a negative 1 and a positive 1. Your vertex then is going to be at 0. So if you look at negative 1 and positive 1, 0 is directly in the middle. So it's a pretty easy table to kind of make up. Here are your zeros. You plug in 0 to that, you got yourself a negative 4. 1, 2, 3, 4. Now, turns out the next two terms are going to be off the grid. So maybe I should have, and maybe I still could. Instead of count by 4s, if I want it to fit, maybe I'll plug in something else. But if I plug in a 2, 2 squared is equal to 4. 4 times 4 is 16. Minus 4 is 12. So the point that I have here is a 12, and this is a 12. So maybe instead of counting by ones, I count by 2s. So if I say that's a negative 2, negative 4, negative 6, I can label negative 4 right there, and then that would mean I'd be going 2, 4, 6, 8, 10, and 12. That allows me then the luxury of plotting every point. I'm just counting by 2s now. So the high point would be there, and even though I'm counting by 2s, it still seems very stretched, but at least it fits on the grid. And our vertex, then we said, was 0, negative 4.